Hello friends, welcome to lecture number 4 of gamma function mathematical physics for BSc and MSc students. So here we're going to solve different types of problems. I have taken those problems from the mathematical physics books by HK Das. Okay, so before you watch this video, that I would like to suggest please watch lecture number 3. Okay, then only you will understand better. Okay, so now let's start. So here is the first question. We're going to solve this. So now let us solve this one. So what we're going to do here, we can write this as 0 to infinity x to the power half, right? Root x can be written as x to the power half e to the power minus x dx, right? Then now you see, we know the definition of gamma n, that is equal to 0 to infinity, integration 0 to infinity x to the power n minus 1 e to the power minus x dx, right? E to the power minus x dx. So now you see, we can write this x to the power half as x to the power 3 by 2 minus 1. Then only we can compare with this, right? So what are we going to do now? You can write this as 0 to infinity, then half can be written as 1 and half minus 1, that means 3 by 2 minus 1 e to the power minus x dx. Then by definition, so here the value of n is nothing but 3 by 2, so that's why we have got here gamma 3 by 2 and gamma 3 by 2. Now you can simplify this, that we know that gamma n plus 1 is equal to n into gamma n. So 3 by 2 is nothing but gamma 3 by 2 is nothing but gamma half plus 1. So that's why we can write half gamma half, right? Half and gamma half. So we can write this as half gamma half, and gamma half is root over pi, so that's why half into root over pi. This is our answer. Okay, now let's move on to the next question. This is our next question. We're going to solve this. Here is the expression given integral. So let me take this one as I. So here you can see, we know that ddx of x square is twice x, right? So now you see what we're going to do here. Let me write this one as 0 to infinity x to the power. Here it will be more clear if I show you this way, that here we have x square, right? So x square, if you take this one as t, then what will be the result? Then twice x will be dt by dx, right? And here we're going to write so we're going to have x dx is equal to dt by 2, right? So that's why, so in order to make this x dx, so let me write x cube e to the power minus x square x dx, right? Now let us use this. Okay, so now let us put x square is equal to t, so we can write x dx as dt by 2. So then I will be equal to, now you see, this x cube can be written as we have taken x square is equal to t, so x will be equal to t to the power half, right? T to the power half. So here we have x cube, so then t to the power half whole cube, that means t to the power 3 by 2, right? So that's why we can write, and this I going to be equal to 0 to infinity, integral 0 to infinity t to the power 3 by 2 e to the power minus x square is taken as t, and x dx is nothing but dt by 2. So we're going to write dt by 2. So we can write this constant, we can write the constant outside. So then integration 0 to infinity t to the power 3 by 2 can be written as 5 by 2 minus 1, right? 5 by 2 minus 1, then e to the power minus t dt, right? Again, from this definition, gamma n is equal to 0 to infinity x to the power n minus 1 e to the power minus x dx. Okay, if you compare with this, then you will find that value of n is here 5 by 2. So the result will be gamma 5 by 2. That's going to be gamma 5 by 2. Now this gamma 5 by 2, here you see, let me clean these things. Okay, now what we can do, we can apply this gamma n plus 1 is equal to n gamma n. Okay, if you apply this, here you see 5 by 2, gamma 5 by 2 can be written as gamma, this is gamma function, 3 by 2 plus half, 3 by 2, sorry, not half, 3 by 2 plus 1, 3 by 2 plus 1. So according to this identity, it can be written as 3 by 2 gamma 3 by 2. Again 3 by 2 can be written as half plus 1, that's why it can be written as 3 by 2 1 by 2 then gamma 1 by 2, right? So we're gonna have that I is equal to gamma 5 by 2 will be equal to 3 by 2 into 1 by 2 then gamma 1 by 2, right? We're gonna have gamma 1 by 2, and gamma 1 by 2 is pi, so here we're gonna have 3 by 4 and square root of pi, gamma 1 by 2 is pi, so this is our answer. So hope you have understood this. And one more thing, I forgot to multiply this half, so here we should have 1/2, so 1 by 2 into this, that's gonna be 3 by 8, so this should be our result, 3 by 8 pi. So hope you have understood. Now let's move on to the next question. Now let us solve this question. Here you see, so first let me write the given expression. This is the given expression. So here we have x square, so let us consider x square as t. So we have taken x square as t, so we can write x is equal to t to the power 1 by 2, right? And if you differentiate this with respect to x on both sides, then you will get this result, which implies x dx is equal to half dt, right? So then from then here you see this integral will be equal to here we will get I is equal to 1 by 2 integration from 0 to infinity e to the power minus ac square. X square is replaced by t, x square is replaced by t, and here you see, and t will be replaced by x will be replaced by t to the power half, right? This x is replaced by t to the power half, so I forgot here actually we should have dx, right? Here you can see as x ds is equal to half dt, so what we can do here, we can write this expression like this, 0 to infinity e to the power minus ac square x square and x to the power minus n into x dx, right? So we can replace this x to the power minus n, we can replace x by t to the power half, right? So x to the power minus n will be minus 1 will be t to the power minus half, right? So x to the power minus half will be t to the power minus half. So here we will write t to the power minus half, and this x dx will be replaced by half dt, half is written already outside, so here we're going to write dt, right? So now what we're going to do, we're going to apply this identity that we have already discussed in the last class. So if you haven't watched those last lectures, so please go through them, okay? From lecture 1 to lecture 3, watch all the videos, okay? So here you see we have already discussed this, that 0 to infinity e to the power minus k y and y to the power n minus 1 dy, that's going to be gamma n by k to the power n. So here we can consider ac square as k, right? So if you compare this 0 to infinity e to the power minus ac square with k and t with y, then y to the power n minus 1 with this t to the power, you can write minus half as half minus 1, right? This t to the power half can be written as half minus 1. So then what are you going to have? So value of n is half, so gamma half divided by k to the power n. So k is here h square, so h square whole to the power n is half here, right? So here you can see, let me write one more step, 0 to infinity e to the power minus h square t, then t to the power minus half is written as half minus 1 dt, then this result gonna be equal to this, right? Gamma half divided by h square whole to the power half, and we have one more half here, so let me write that half here. Okay, so this is going to be equal to 1 by 2h, and gamma half is square root of pi, right? So this is our answer. So hope you have understood this. Now let's move on to the next question. Now let us solve this question. So let me write the given expression, given integral. So this is the given integral. So what we can do here, we can write this too as like this. Okay, so here you see integral 0 to infinity. So you can write these things as e to the power minus ax square into e to the power minus by square, right? And you can write this x square whole to the power, and so what you can do here, you see, we know that if you differentiate this, then you will get twice x, right? And if you take this as t, right, if you consider this one x square as t, then you will get 2x dx is equal to dt, right? So here you will get x dx. So that's why in order to deal with this, what we're gonna write, we're gonna write this one as x twice m minus 1 minus 2, and we will multiply x, so then we will get x dx, right? So and that is what we're going to do here. So what we will get, here you can see, so this expression can be written as we're going to write here x dx, and we're going to write here y dy, right? So hope you have understood this. So from here we have got e to the minus ax square, then from this we have got x square m minus 2 into x dx. This dx is written with this. So if you multiply this two, then again you're gonna have this, and this can be written this way, right? This way. So hope you have understood this. A very simple thing, these things, right? So now let us try to solve one by one. So from here you can see, let's find this integral first. So now, so here we will get 0 to infinity, and e to the power minus a x square is replaced by t to the power m minus 1, and dt by 2 is this half is taken outside, right? So we're gonna get this. So this will be equal to, so according to this identity here, you see, as we have already discussed this, integration 0 to infinity e to the power minus ky into y to the power n minus 1 dy, which is equal to gamma n by k to the power n. So here if you compare this expression with this, here you will get k is nothing but a, and y to the power n minus 1 is this t to the power m minus 1. So instead of m we're gonna get n, right? Instead of n we're gonna get m. So the result supposed to be like this, that gamma m by k is here a to the power m, and here we have half, so that's why this half should be written here 1 by 2. So hope you have understood this. So similarly, if you consider that y square is equal to t or something else, then you will get similarly you can evaluate 0 to infinity e to the power. So as we have got same kind of expression, only the symbols are different, y and x, okay? So that's why instead of showing the whole process, procedure, you can just directly write the result using this pattern. So that's gonna be here, instead of m we have n, so half gamma n divided by, instead of a we have b, so b to the power n. So these two results we have got. So now let us use these two results. Let us use these two results here. Then you will get the value of I. So let me go to the next. Just let me do a little bit of adjustment. Just wait. So simply just let me adjust this way. Okay, so I hide this question, right? Okay, so now what we have got, using these two results here, we have got I is equal to this. I is equal to half gamma m by a to the power m into half gamma n by b to the power n. If you multiply these two, you're gonna have 1 by 4 gamma n divided by a to the power m and b to the power n. So this is our answer, right? So now let's move on to the next. So now let us solve this question. Here you see, first 0 to infinity, 0 to 1, integration 0 to 1 dx by root over 1 minus log of x. So you see, minus log of x, it can be written as log of x to the power minus 1. X to the power minus 1 means 1 by x, right? So log of minus log of x can be written as log of 1 by x. So as there is square root, so we can write this whole to the power half, right? Whole to the power half. So this can be written as 0 to 1 dx by log of 1 by x to the power half. So which also can be written as 0 to 1 log of 1 by x to the power minus half dx, right? Very simple simplification. So here you see, now in this case we are going to apply this identity, that is what, integration from 0 to 1 log of 1 by x. We have already discussed in the last lecture, so if you haven't watched, go watch them, then you will understand. Okay, so we're going to apply this n minus 1 dx. Okay, this is equal to gamma n, right? So we have got this identity in the last lecture, lecture number 3. So what's that first, then come to this video. Okay, then it will help you to understand better. Okay, so now you see, so in this case, this minus half can be written as 1 minus, you can write half minus 1, then it becomes minus half, right? Then compare this one with n minus 1, then you will get n is equal to half, right? Hope you have understood this. So let me write one more step. Okay, just wait. So we can write this as 0 to 1 log of 1 by x minus half can be written as half minus 1, which again gives minus half, right? Dx. Now compare this one with this, then you will get n is equal to half, right? So if n is half and this is equal to gamma n, so it's gonna be equal to gamma half, right? And gamma half is nothing but square root of pi. This is square root of pi. So this is our answer. So hope you have understood. Now let's move on to next question. Now you see, this is the next question. Here we're going to solve this question. So now here 0 to 1, integration 0 to 1 by root over x log of 1 by x dx, right? This is what we have got. Now in this case, let us consider that as I have already discussed that I have already explained that log of 1 by x, which is equal to minus log of x, right? that is nothing but minus log of x. So now let us consider that let us consider minus log of x, that's going to be equal to let us consider this is equal to t. Okay, so if this is t, then we can say that log of x is equal to minus t, right? Log of x is equal to minus t. So here log of x means here base is e, right? Okay, base is e. So now we can write, you see, you know this property of log, that log m base a is equal to n. What does it mean? It means a to the power n is equal to m, right? So here we have the base e, so that's why it will be e to the power minus t, which is equal to x, right, from this property. So hope you have understood this. So now what we can do, now let us differentiate both sides. Okay, now let us differentiate both sides with respect to t. Then what you will get, if you differentiate this with respect to t, then you will get minus e to the power minus t, right? And if you differentiate it with respect to t, then you're gonna have dx dt, so which implies dx is equal to minus e to the power minus t dt, right? That's what we will get, right? Now using these values in the given expression, what we're gonna have, that you see, before putting this value, let me simplify this expression. So this can be written as integration 0 to 1 x log of 1 by x whole to the power minus half, right, dx. Then again it can be written as 0 to 1 x to the power minus half, and this log of 1 by x we can write minus log of x whole to the power minus half, because we can replace this minus log of x by t, right? So hope you have understood this. So now you see, so I forgot the dx. Okay, so if you replace these integrals with these results, that minus log of x replaced by t, then x will be replaced by e to the power minus t, then what happens? Now you see, consider these things. Now consider this thing. So here you can see, so just wait. So now you see, so when we have the integral from 0 to infinity, then we had the expressions of x here, right? F of x, okay, functions of x dx, right? These are functions of x. So this function of x. So now you see, when you make it function of t, right, then the limit will be also changed. When you see x is equal to 0, when this x equal to 0, okay, when you're gonna get here 0, when you will have e to the power minus infinity, right? So that means for t is equal to infinity, you're gonna have x is equal to 0. Then when you will get x is equal to 1, right, when you will get x is equal to 1, so when you will get 1 here, when you will get e to the power minus 0, or you can say simply e to the power 0, right? So that means, so when x will be equal to 1, then t must be equal to 0, right? So when you will replace by these values of x with the when you will replace this function of x with function of replaced by function of t, then the interval will be changed from infinity to 0, and x is nothing, you see, x is nothing but, we have considered here that sorry, not this one, x is nothing but e to the power minus t. So that's why x will be replaced by e to the power minus t, then we have whole to the power minus half, right? Then minus log of x, minus log x is equal to t, so let us replace it by t. Then we have power minus half, so here minus half, then dx will be replaced by, so here you can see dx is nothing but e minus e to the power minus t dt. Okay, so we can write minus e to the power, just wait, minus e to the power minus t, then dt. That is what we're gonna have, right? So now let me clean these things. Okay, so now just wait. So here you see, so if you simplify this further, then what you will get, so you see this minus will be taken out. Okay, minus infinity to 0, then e to the power minus t, e to the power minus t minus half, so whole to the power minus half, then you will get e to the power minus t, that minus half plus 1, that means plus half, right? That's going to be equal to plus half. That means if you multiply these two, then you're going to have e to the power minus t whole to the power plus half, and this minus is taken out, right? So hope you have understood this. So now you see, and also we have t to the power minus half, then dt, and if you make it positive, then the limit will be, the upper limit will be the lower, and lower limit will be the upper limit. Okay, so integration from 0 to infinity. Then here you see, now what we can do, we can write t to the power minus half e to the power minus t into half means t by 2 dt. That is what we have got, right? So sorry, here we should not write implies, that should be equal sign. Okay, now let me copy this last step and let me go to the next slide. Okay, let me copy this one and let me go to the next slide. So this is the new slide. Okay, so here what we're going to do, so again you see, let us take that t to the power 2 is equal to suppose p, right? Then if you differentiate it with respect to p, then what you will get, or if you differentiate it with respect to t, then you will get half dp by dt, which is going to be equal to dp is equal to, which is going to imply dp is equal to dt into half, right? So this is what we have. So now from this expression 0 to infinity, so here you see, if t by 2 is equal to p, then t definitely will be equal to 2p, so t will be replaced by 2p whole to the power minus half, so this t is replaced by 2p, right? Then e to the power minus t by 2 is nothing but we have considered p, right? Minus t by 2 we have t by 2 we have considered p, so here minus t by 2 is minus p, then dt will be replaced by so if you bring this 2 here, 2 dp, right? So dt will be replaced by twice dp, right? So here we will get dp and 2 is written outside. Okay, so hope you have understood this. Now you see, from here, from this term we're gonna have two things, that is 2 to the power minus half and p to the power minus half, and this 2 to the power minus half, when it will be multiplied by 2, then you're gonna have 2 to the power plus half, right? You're gonna have 2 to the power plus half. So we can write that 2 to the power half integration 0 to infinity p to the power minus 1 by 2 e to the power minus p dp. That is what we're gonna have, right? So now let me clean these things, just wait. Okay, now let me do a little bit of adjustment. So here let me write here. Okay, So just wait. So here we had 0 to infinity, there was 2, right? Okay, this is 2, 0 to infinity. So now what we're going to do here, then 2 to the power half means this is root 2, not gamma 2, this is root 2, 0 to infinity. So p to the power minus half can be written as half minus 1, right? Then p to the power minus p dp, sorry, that should be e to the power minus p dp. Now we know the definition of gamma function, that is gamma n is equal to integration from 0 to infinity x to the power n minus 1 e to the power minus x dx. So here you see, if you compare these two, the only different thing is here x is p, okay, and otherwise all the things are same. If you compare this part with this, then here you can see that n is nothing but here half, right? So we're gonna have gamma half after application of this formula. So we're gonna have root 2 then gamma half. Okay, this is gamma half, not root half. Okay, so gamma half is nothing but pi, square root of pi. So root 2 into root pi, which can be written as root over 2 pi. So this is our answer. So hope you have understood this. So here you can see, let me write the given expression first. Now we're going to consider that minus log of x is equal to t, or you can say log of x is equal to minus t. Where I have taken minus t, I will explain it. So if log of x is equal to minus t, then we can write e to the power minus t is equal to x, right? So we can write e to the power minus t is equal to x. So as we have considered, log of x is equal to minus t, right? So now you see here we have lower limit 0, upper limit 1, right? So when you see t is infinity, for t is equal to infinity, x will be 0, right? When you will get infinity here, because e to the power minus infinity is 0, that's why we have taken here minus t in order to get e to the power minus t. Okay, so and then for t tends to infinity, x tends to 0, right? So here you see, then if t is 0, when t is 0, then x will be equal to 1. If you put 0 here, then this x will be equal to 1. So and so we can change this upper and lower limit to from you say infinity to 0. That's why we have done these things, right? So now you can see that if you differentiate it, you will get 1 by x minus dt by dx, which implies 1 by x dx minus dt, right, equal to minus dt. So that's what we will get, right? Now this given expression, this can be written in this form, right? So I have written x to the power 3 as x to the power 4, then we have multiplied 1 by x, so which is going to give you again x to the power 3, right? So hope you have understood this. Now you see, this is log of x, here we have cube, so we have got this is log of x whole cube, right? So now replace this x log x 1 by x dx by these values we have got here, right? Okay, so log of x will be replaced by minus t, e to the power minus t will be x will be replaced by e to the power minus t, then and 1 by x dx will be replaced by minus dt, right? So here you can see, so that doing so, what we will get, we're gonna have this step, right? So here as x is equal to minus t, so x to the power 4 will be e to the power minus 4t, right? So hope you have understood this. So similarly, log of x is replaced by minus t, log of x is replaced by minus t as we have considered, then this one is replaced by minus dt, right? So hope you have understood. And so here you can see that this minus, there is odd power, so negative remains negative, negative it becomes positive, so we will get this. So if you make this upper limit lower, if you change the limits, interchange the upper and lower limits, then there should be a minus sign, Okay, that's why we have got this, and this minus becomes plus, and we have t to the power 3, which can be written as t to the power 4 minus 1, right? So now here we're going to apply this identity. This is equal to, here you see, e to the power minus ky y to the power n minus 1 dy, that is gamma n by k to the power n. So here in this expression, this 4 can be compared with k, and this 4 can be compared with n, right? Then its result will be, there is minus sign, so minus, so it should be gamma n. So here n is nothing but 4, right? So we can write that so here value of n is 4, so gamma 4 divided by k to the power n. Here k is nothing but 4, right? If you compare with this, then this k is here 4, right? So we can write 4, and to the power n, here n is, if you compare this n with this, then you're gonna have 4, so 4 to the power 4. That is what we will get. So here you can say, as we have minus sign here, so let me write this one here, just wait. So here you can see we have minus sign here, so there should be a negative. So if you evaluate this, then what you will get, gamma 4 is nothing but, you know, gamma n is nothing but n minus 1 factorial 1, n minus 1 factorial, or you can say gamma n plus 1. Gamma n plus 1 is factorial n. If you apply that, so here this is gamma 4 means factorial 3, right? And factorial 3 is nothing but 3 into 2 into 1, 3 into 2 into 1, and 4 to the power 4 is nothing but 4 to the power 4, that will be 256, right? 4 4 are 16, 4 4 are 16, 16 are 256. So here you see, and if you, after cancellation, if you cancel this the denominator by 2, then you're gonna have 128, right, as numerator, right? 128. So our result will be minus 3 by 128. So this is our answer, right? So this is our answer. So hope you have understood this. So this is the answer, minus 3 by 128. So now let's move on to next question. Now let us solve this. Okay, so here you can see that integration from 0 to infinity e to the power minus y 1 by m dy. So here let us consider that y to the power 1 by m is equal to t. Let us consider this is equal to t. Then we can say y will be equal to t to the power m, right? Then if you differentiate with respect to y, if you differentiate this with respect to y, then you're gonna have 1 by m y to the power 1 by m minus 1 is equal to dt by dy. That is what we're gonna have, right? So in that case, dt will be equal to 1 by m y to the power 1 by m minus 1 dy. That is what we're gonna have, right? So this is the value of dt. So now here you see, as we have dy, so let me write this result in terms of dy. Just wait. So let me write that way. So from here you can write dy is equal to, so 1 by m will be m, and y to the power 1 minus 1 by m dt, right? So hope you have understood what we have done. We're supposed to get 1 by y is equal to dt by, so 1 by m y to the power 1 minus m minus 1, right? So this simply this implies this, right? So hope you have understood this. So now let me clean these things. Okay, so here you see, so what we're going to do here, here limits will remain same, because for y is equal to 0, t will be equal to 0, right? For y is equal to 1, t will be also equal to 1. So limits gonna be limits gonna remain unchanged here. So 0 to infinity, so we should not write here implies 0 to infinity. So e to the power minus 1 by m, that's going to be e to the power minus t. Then dy will be replaced by this, dy will be replaced by this value. So then we have got m y to the power 1 minus 1 by m dt, and this y will be replaced by again t to the power m. So that's why we're going to write here t to the power m, right? T to the power m whole to the power 1 minus 1 by m. So hope you have understood this. So here you can see this m, this y going to be replaced by this t to the power m, then again 1 minus whole to the power 1 minus m whole to the power 1 minus m, then dt. That's what we got, right? So now if you simplify this, then what you're gonna have, so after simplification 0 to infinity, then e to the power minus t, this m is taken as constant, so here m is taken outside, then t to the power, if you multiply this m with this power, then what you will get, m minus 1, right, dt. Now by definition of gamma function 0 to infinity x to the power n minus 1 e to the power minus x dx is nothing but gamma n, right? So here compare this one with this and this one with this, then you should get this one as gamma m. So this is our answer. So hope you have understood this. So this is what we have got. So here the question was something like this, prove this is equal to m gamma m. So hence it is proved, right? So now let's move on to next question. So here we have to prove this. Okay, so first let me write n. So instead of solution, let me write here proof. So n plus half, gamma n plus half. So it can be written as n minus half plus 1, right? N minus 1 plus 1. So n minus half plus 1. We know that n plus 1 is n gamma n, right? Let us apply this. So n minus 1, in this case n is n minus half, right? So then we're going to have n minus half gamma. So this is not square root, this is gamma function, right? This is gamma. Okay, so gamma of n minus half, right? We're gonna get this. Again, this n minus half, it can be written as, now you see, here you can see, instead of writing this, we can write this way also, gamma n, then n minus 1 of gamma n minus 1. Okay, so if you apply these things here, 1 by 2, n minus 1 by 2, so this can be written as n minus 1 by 2 minus 1, then again gamma of n minus 1 by 2 minus 1, right? So this is going to be n minus 3 by 2, and this is going to be also n minus 3 by 2, right? So simply we can write n minus 3 by 2 into gamma of n minus 3 by 2, because here you see n minus half minus 1. So if you take this minus sign common, this is going to be plus, then n minus 2 will be LCM, 1 plus 2 by 2, that's going to be 3 by 2, right? So this is very simple simplification that you should know, right? Then if you continue this process, you should get n minus half, sorry, n minus half, n minus 3 by 2. Then next you're gonna have, that means you can write this identity this way: n minus 1, then n minus 2, then n minus 3, and dot 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 dot, so on, 3 dot 2 dot 1, and so on, right? So hope you have understood this. So similarly here also you can write n minus 3 by 2, then again minus 1, then it will be 5 minus 2, then again if you subtract 1 from it, then you're gonna have n minus 7 by 2, right? So and so on. At the end, what you're gonna have, just wait, let me write here. Let me write it. I started from here. Okay, here you see, as we have got here 3 to 1, in this case at the end we're supposed to get 3 to 1, right? Okay, when you expand this gamma n, so 2 into 1, which can be written as factorial 2. Factorial 2 means, according to this identity, that should be sorry, not this identity, we know that gamma n plus 1 is factorial n. So according to this factorial 2 should be equal to gamma 3, right? Gamma 3. Now you see, after simplification of same number of steps that we have done here, if you do so here, then what we will get, now you see this factorial gamma 3 can be written as, so there is n, so we can write n minus 3, right? Okay, now here you see, just if you see, if we simplify this, right, if we simplify this, okay, same number of same number of times, how many times we're going to simplify, that same number of times we have simplified here, then after same number of steps, so what we're going to have, so here we have n, but here n plus half, so that then here we're going to have, right, so that here we're going to have n plus half, instead of this m we're going to have n plus half. Then so as we have performed same number of steps of simplification as we have done here, then this n minus 3 will remain same, n minus 3, right? Okay, so hope this point is clear to you, right? So here you see, then you can take LCM here, doing so 2n minus 1 by 2, then 2n minus 3 by 2, then dot 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 dot, you're gonna have here gamma 5 by 2, okay, gamma 5 by 2. Now let me take this result, let me copy this result, and let me go to the new slide. Okay, so here just wait. Okay, so this is nothing but gamma n plus half, right? This is gamma n plus half. So now this is the new slide. So here you can see 2n plus n minus 1 into 2n minus 3 by 2 into 2n minus 4, sorry, not, it's supposed to be 5 by 2, and dot dot dot. So here gamma 5 by 2 means here you see that's gonna be equal to 3 by 2, gamma again 3 by 2, and gamma 3 by 2 is 1 by 2, and gamma 1 by 2, and gamma 1 by 2 is equal to square root of half, right? So we're gonna have square root of half. So for the first time, for this time, let me write here gamma half. Okay, so here you can see, in this case, so as we have simplified n times this, so there must be 2n, okay, sorry, n number of 2's, because let me show you one more thing here. If you observe this series, twice n minus 1 into twice n minus 2, sorry, not 2, 3, and twice n minus 5, and dot 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 3 into 1, right? 3 into 1 into let me write this one, square root pi, and 2 to the power, what you should write. Now you see, this series can be written in this way. If you reverse the order 1 3 5 dot 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 2n minus 5 into 2n minus 3 into 2n minus 1, and you can write this way. So here you see, this 1 can be written as 2 into 1 minus 1, right? This 3 can be written as 2 into 2 minus 1, right? Sorry, not, yes, minus 1. Then this 5 can be written as 2 into 3 minus 1, right? And so on. So similarly, this can be written as twice n minus 2 minus 1, and this is 2n minus 3 minus 1, right? And here twice n minus 1, right? Sorry, actually this should be twice n minus 1, that should be minus 1, okay? And this is twice n minus 1, right? So we can write this way. So here you see, here we have 1, this is for the first term, this is 2 for the second term, this is 3, this is third term, right? And this is 2 minus 1 means 2 minus 1 term, this is 2 n minus 2 term, right? This is n minus 1 means n minus 1 term, right? So here we have n means nth term, right? So that means there are n number of terms from here to there. There are n number of terms. So that's why in the denominator we should have n number of 2's. So that's why we can write here 2 to the power n. Let me clean these things. So we can write here 2 to the power n. Let me explain it again if you are confused. 1 into 2 into 3 into dot 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 dot, that is 2n minus 5, 2n minus 3, and 2n minus 1, right? So here you can see this 1 can be written as 2 into 1 minus 1, that's going to be again 1. This 2 can be written as 2 into 2 minus 1. This is second term, this is the first term, right? And third term can be written as 2 into 3 minus 1. When you have written the third term, here is 3. When you have written the second term, here we have got 2. When for the first term, here we have got 1. So here we have got 2 into n minus 1 means that is nth term, right? So here you see, if this is nth term, this is supposed to be n minus 1 term. Let me check. So this can be written as 2n minus 2 minus 1, right? Minus 2 minus 1, right? And this can be written as, on taking 2 common, n minus 1 minus 1. So here you can observe that clearly this is n minus 1, so this must be n minus 1 term. As if it is n, then that is nth term. When there was 3, here you can see 2 into 3, that is third term. When you have 2 here, this is 2 into 2, that is second term. So when we have 1 here, 2 into 1 minus 1. So when we have got 1 here, when we have got 2 into 1 minus 1, then this is first term, right? So hope it is clear. So that's why, as this is 2 into n minus 1, here we have n, so it must be nth term. So that's why, so number of 2's must be n, so that's why 2 to the power n, right? So I hope you have understood this thing. So now here you can see what we're going to do. So if you simplify this, then you will get this result, n plus half. So let's multiply this one with this, then that side will be divided by square root of pi, and that's how we have got this result, right? And this is what we needed to prove. Okay, so hope you have understood. Please stay connected and subscribe the channel if you're new to my channel, and share with your friends, hit the bell icon so that you get notified when new video will be uploaded. Okay, so thank you for watching.